Warning: the following show features stunts performed either by professionals or under the supervision of professionals. Accordingly, DI, Jay-Z, and the producers must insist that no one attempt to recreate or reenact any stunt or activity performed on this show.
These are the calculations that are done behind the scenes. This is a test that most people use to test the brakes of a car.
In M3.
So, what exactly is the science behind this clip?
Now, in an emergency, a driver brings the car to a full stop in 5 seconds. The car is traveling along a highway rate of 24.6 meters per second when braking begins. At what rate is the car decelerated? Well, our givens are that we have 5 seconds, which would be our time, 24.6 meters per second, which is our speed or velocity in this circumstance, and we know that our acceleration, and we don't know our acceleration. We know that our final velocity is 0 because it's a full stop. Now, let's see what formula we can use. Final velocity is equal to initial velocity plus acceleration times time. Now we have final velocity, we have initial velocity, and we have time. So we have all the variables except one. Now let's plug in. Now our final velocity being 0 is equal to our initial velocity, which is 24.6 meters per second, times your acceleration, plus your acceleration, which we do not know, times your time, which would be 5 seconds. And we want to make sure that we always use the same variable. So for acceleration, you get 8, so we won't be confused. Now, if we simplify, let's simplify. So, but first, let's go over our answers. We got our final velocity because the car came to a full stop. We got our time because it took the car 5 seconds to go to that full stop. And we got our initial velocity, which is 24.6 meters per second, because it was going at a rate of 24.6 meters per second when the braking began. Now, just forgot to write one given, and our final velocity is 0. That was Jake, I apologize. Now, let's simplify. Negative 24.6 is equal to A times 5, or 5, A5. Now, let's divide by 5 on both sides to isolate the variable. And we get A is equal to negative 4.95. Now, moving on to question B. How far does it travel before stopping? Now, we know our time is 5 seconds. We know our initial velocity is 24.6 meters per second. We know that our final velocity is 0. And we know that our acceleration is now negative 4.95. Now, the equation that we decided to use, since we have all 4 and we just want to solve for the distance, is the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. So 0, our final velocity, is equal to the initial velocity, 24.6, squared, and we don't want to forget to square both sides. Sorry. So square 0 squared, and 24.6 squared, plus 2 times the acceleration times the distance. Now the acceleration is negative 4.95, and the distance is what we are solving for, so we're going to put a D to not get confused. Now, first we're going to do the exponents, get those out of the way, so 0 is just 0, 24.6 squared will be 605.16 plus 2 times 4.95 should be 9.9 negative times the distance, which we don't know. Now, we're actually going to subtract 605 and put it on the other side. Okay, sorry. So negative 605.16 is equal to negative 9.9 times the distance. So when divided by 9.9 negative, divide the other side by negative 9.9, and we get 61.12.127 is the distance. So 661.127 is going to be in the meters. And we don't want to forget our units, so we want to make sure we know all of our units. So we've kind of forgotten the acceleration, but it's okay because we haven't completed our problems yet. And so, what I want to say is never forget to write your units. dictate whatever. Action. Go. Action. And